Can you expand a little bit more on an example of some of those twins in a factory?
Sure. So everybody should be familiar with a product twin. If I'm making a product, I want to instantiate an object that is in 3D. I can render the 3D, I can analyze it, I can simulate it. The same holds true for larger systems. So on the process side, how large is that system? It could be as simple as one single robot in a workstation. Could be two robots in a workstation. And am I synchronizing those, taking into consideration things like collision avoidance, doing my virtual commissioning, and then go to a production line, where I'm actually automating a production line, or an entire factory. And the intent is, especially with a factory twin, is how can I model and simulate in the advance of making any kind of change or building a facility. So I'll tell you, historically, I've walked into plants and you see people with paper cutouts on the ground, essentially doing space reservations of where their equipment's going to go. And then the next progress forward is to have cardboard boxes that actually do 3D representations. You just hope you don't go by on a windy day and it sets you back a little bit.
Right.
But so people move and manipulate these cardboard boxes to try to build a factory. Well, in modern days, now you can do it digitally. So you can either do it digitally with space representations by dragging in a block that consumes space, all the way through doing a 3D virtual scan with photorealistic results that digitize an entire factory. And then you can break those objects down, cut sections out, replace the digital content with a supplier-provided drawings or CAD models. And it really gives you the ability to model and simulate everything, including the size of the objects, the performance of the objects, and how they work together.